Number 1, principal quantum number. Symbol is n, that is an integer. Values can be 1, 2, 3, 4, 5 and so on. Significance. A represents the major energy level, that is shell or orbit. Therefore, n equal to 1 means first orbit or K shell. N equal to 2 means second orbit or L shell and so on. B. More is the value of n, more is the size of the shell. C. More is the value of n, higher is the energy level of the electron, and hence it is less tightly held by the nucleus. Number 2, azimuthal or angular quantum number. Symbol L. Values for each value of n. There will be n values possible for L, but they will be from 0 to n minus 1. Thus, for n equal to 1, L will have only one value, and that is 0. For n equal to 2, L will have two values, 0 and 1. N equal to 3, L will have three values, 0, 1 and 2 and so on. Significance. A. L denotes the type of the subshell. Thus, if L is equal to 0, it means S subshell. L equal to 1 means P subshell. L equal to 2 means D subshell. L equal to 3 means F subshell. Therefore, if for an electron n equal to 1 and L equal to 0, it means it belongs to 1s. If n equal to 3, L equal to 2, that means it belongs to 3D subshell. B. The angular momentum of an electron in an orbital or subshell is given by under root L into L plus 1 multiplied by h upon 2 pi. Thus, the angular momentum of an electron in 1s orbital, say hydrogen atom, that's equal to 0, because L is equal to 0 for any S subshell. C. Within a shell, the order of energy level for the subshells is S less than P less than D less than F. Number 3, magnetic quantum number. Symbol M. Value for each value of L. There are 2L plus 1 values of M possible, but they are from minus L to plus L. For example, if L is equal to 0, then M is also equal to 0. If L is equal to 1, then M will have three values, which are minus 1, 0 and plus 1. For L equal to 2, then M will be equal to minus 2, minus 1, 0, plus 1 and plus 2. For L equal to 3, M will have 7 values, which are minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. Significance. A. Each value of M represents an orbital for that subshell. Thus, for L equal to 0, M is also equal to 0. It represents S subshell as well as S orbital. That is only one orientation. For L equal to 1, M has got three values, minus 1, 0 and plus 1. These three values represent three orientations of a p subshell. We have already read that a p subshell has three orbitals, namely px, py and pz. Though there is nothing like man-to-man marking, yet according to some convention, m is equal to 0 is assigned to pz orbital. Hence, L equal to 1 represents p subshell. M will have three values, -1, 0 and +1. We can assign -1 to px, 0 to pz and +1 to py orbital. Similarly, for L equal to 2, it represents d subshell. Then M will have five values, -2, -1, 0, +1 and +2, representing five types of orbitals. We can assign these numbers to the following orbitals: -2 to dxy, -1 to dyz, 0 to dz square, +1 to dzx and +2 for dx square minus y square. B. In fact, in the absence of magnetic field, all the three p orbitals are equivalent, that is, of equal energy, and hence are called degenerate orbitals. Similarly, all the five d orbitals of a subshell and all the seven orbitals of a f subshell are degenerate. Last, number 4, spin quantum number. Symbol S or ms. Value. For each value of m, there are two values of s or ms possible, which are +1/2 and -1/2. Significance. A. These two values indicate about the direction of spin of an electron. Thus, if we consider +1/2 for clockwise, then -1/2 will be for anti-clockwise spin of an electron. But it should be clearly understood that there is nothing like actual spin of an electron going on inside an atom. Here, it is only in the form of a concept. B. Spin angular momentum for an electron is given by under root s into s plus 1 multiplied by h/2 pi, where s is equal to 1/2. C. This concept of electron spin was given by Uhlenbeck and Goudsmit in order to explain the fine structure of spectral lines.